Good morning to all of you. Greeting from Cairo. I'm Rifaat Abdel. I'm professor of water and wastewater technology. I'm a professor at the National Research Center in Cairo and currently the head sector of research and development at the holding company. I'm pleased to moderate the second session of water management and system maintenance of the International Operation and Maintenance Conference in Arab countries under the theme of the integration of maintenance and asset management. We have the title of the session, as I said, water management and the system maintenance. We have three esteemed speakers. The first speaker, Dr. Norbert Hanigovszki, and the second speaker, Engineer Ibrahim Al Abbassy from King Saudi Arabia. The third speaker, Engineer Tom Sevenstein. I think he's not in so far, but we'll try to get him in very soon from Denmark. Let's introduce our esteemed speaker from Denmark, Dr. Norbert. Dr. Norbert is technology director of Danfoss drives in Græsten, Denmark. He is leading the drives intelligence department, focusing on the theme such as advanced motor control reliability and also machine learning. He has been with Danfoss since 2002, where he had various positions in R&D department. He has been got a PhD degree from Aalborg University in Denmark and the MSc degree in electric machine and drives from Boltenica University in Romania. So professor or engineering, now I must say Dr. Norbert will speak today about the condition monitoring using a variable speed drive as a sensor. So please, Dr. Norbert, the floor is for you. Go ahead. You have 15 minutes to present your presentation, and then we'll open the discussion at the end of the session. So please go ahead.
Yes, thank you very much. Thank you for the nice introduction and the opportunity to speak at this conference. My topic today is condition monitoring using variable speed drives, and you might ask why condition monitoring using variable speed drives. That's because usually we think about condition monitoring as some additional equipment which we put to monitor the condition of our application. In case of water application, for example, a pumping system. And this is usually an additional...
Could you share the screen?
I'm sharing the video. I have the screen here.
No, I didn't have it. Have you seen it, Engineer Ibrahim?
No.
No, it's on my video. It's on my image.
No, it is not ours. It's not in mine. Something wrong with the presentation.
Okay. How about now?
No.
Better?
It's not.
I'm not in the control of the main stage. The director needs to put us on the main stage. Says we can see it. They can see it.
Have you seen it, Ibrahim? Yeah.
No.
Yes, now we are on the main stage.
Yes.
Yeah. No. Okay.
Yeah.
Yes.
Now. Okay. Good. So don't worry. Nothing is.
Okay. Okay. It's okay now. Go ahead.
So usually condition monitoring, we think about additional equipment put to monitor our application. now we try to do something else and use the variable speed drive for condition monitoring. But let's start with a big picture. Why the variable speed drive? And you see, 50% of all electrical energy in the world is used by electric motors. So that's a lot of energy we use with motors. But by adjusting the speed of the motor to the need of the application, we can typically save. And this is especially true in applications with quadratic torque characteristic like fans and pumps and compressors. So there is a very big opportunity of energy saving using variable speed drives. We can see that up to 8% of global electricity consumption can be saved by 2040 by using variable speed drives. And looking at the water and wastewater sector, we can see that between 30 and 40% of local authorities' total use of electric energy goes to this kind of application. And globally, 8% of the total electricity consumption is used by the water and wastewater sector. And this highlights the importance of using variable speed in water application. But if we look at this example in the picture, you see a variable speed drive that controls a motor, and the motor drives a pump. The pump then pumps water, fresh water in this example. So one role is the power conversion. This is the traditional role where we save 15 to 40% of energy. But what comes now is a change in the role of the drive by adding new opportunities through digitalization. One of the roles is to get information from the motor through analyzing the motor current. And this concept we call drive as a sensor. So we can, analyzing the motor current, we can sense a lot of information from the application. Then you can see in this picture a lot of sensors. These sensors, pressure sensor, temperature sensor, other kind of sensor, they can be connected directly to the drive. And this concept we call drive as a sensor hub. Because the drive is already in the installation, it already has the connectivity and it has the possibility of processing these signals.
Okay.
Then the drive can also be used as a controller for controlling the application. In case of water application, it can be multi-pump cascade application where we have multiple pumps staged in and out depending on the demand. So all this intelligence now comes into the drive, and this enables us to move from corrective maintenance, where we were repairing components which were broken, to a more predictive maintenance or condition-based maintenance, where we see ahead what happens. And this is enabled by the availability of the data sensed by the drive. During the last couple of years, we have worked a lot with condition monitoring using the variable speed drive. And that because condition monitoring is key for condition-based maintenance. And condition monitoring means that we monitor one condition which is degrading in time. And this is shown in this graph here. This is the so-called PEF graph. The change from the P point, which is the potential failure, to the functional failure, the F point. And that is because degradation doesn't happen immediately. It happens in time. And then if we monitor this condition, we can detect a change and trigger a maintenance process. By doing this, we can detect faults at early stage, optimize the maintenance, and reduce the cost of unexpected downtime. But what is very important to remember is that condition-based maintenance requires trained technicians and implementation of maintenance processes. Only having equipment which can do condition monitoring will not do the magic. The real need is the need of people who are able of implementing these. And some of the other speakers will focus a lot and will explain how important these processes are and how important is that people are trained in performing condition-based maintenance. Then to be more specific, we have embedded in the drive 3 functions for condition maintenance, condition monitoring. And these 3 functions are the monitoring of the stator winding. That means if there is an electrical problem in the winding of the motor, the drive will detect that early, before breakdown. Then we implemented a vibration monitoring that's according to ISO 28816 standard. So any change in looseness, eccentricity will be detected. And then a change of the load, so-called load envelope. That means if, for example, in a water pumping application, you get sand in the pump or the impeller gets worn out, then this change will be detected. This, of course, needs also a dedicated commissioning tool so you can visualize these graphs. But then it's not enough to detect this. It's also important to understand how you detect, because the way this works is that the drive learns a normal condition, a so-called baseline, and during this baseline measurement, the information is stored in the drive, and after that, there are set some thresholds. So we set 3 thresholds corresponding to traffic light: yellow, orange, and red. Yellow is the first warning limit, and it means something changes. Orange means it's a change and we need to address it immediately, and red is then the functional failure. Red is when we need to stop the application from running. Now, once we run the application, we compare the actual value with the threshold, and then we can provide the user information, and that can be provided different ways, through wireless display, through bus communication, or through remote monitoring via IoT. But now I have prepared a very, very short demonstration for you, so you can specifically see how this works. We have a drive, and this is the display of the variable speed drive. We have a motor and a pump. And this setup is specially prepared so we can generate some faults. We can generate a vibration fault by lifting the motor. We can make a single turn short circuit in the motor to generate an electrical fault, or we can change here the flow of water in the application. Now I will start the pump. You will get a bit of noise, more noise in the background. And meanwhile, while I'm doing this, I will also show you what happens with the vibration level, for example, if I activate this handle. So you see on the display the vibration level. Now I produce more vibration by inducing usually eccentricity by this handle. And then on the display of the drive, you see there's a warning here, vibration S2. Similarly, if we now go to a stator monitoring, I create a fault by closing the switch, and then you can see the level exceeds the threshold, and the drive provides a warning on stator winding. And now I simulate a fault in the flow. I change the flow of water here, simulating, for example, that the pump is running heavier, and this is again detected by the drive, and I get load warning, and in the same time, you can also see in the graph that the level has exceeded the threshold, and now I remove the fault, and now the application comes to the normal level. So this was only just a short demonstration to show you how it is possible to use the drive for monitoring, for condition monitoring. And this basically is an equipment which is already in place in most water applications. Doesn't need any additional sensors, excepting vibration sensor connected to the drive. So this was my presentation, and I am ready to take questions.
Thank you very much, Dr. Norbert, for your intensive presentation. We'll open the discussion at the end of the session.
Okay, good.
We have some questions, and we'll definitely tell you about that. We'll ask you about that.
Thank you.
So the second presentation from my colleague, Dr. Engineer Abbassi, Ibrahim Abbassi, from King Saudi Arabia. He will be talking about facility management is an investment, not a cost. Actually, Engineer Ibrahim Al Abbassy is the executive senior management with 28 years experience of facility management, operation and maintenance, and the project management experience. He managed current projects within more than 2 billion Saudi Riyal project in Riyadh. Dr. Engineer Abbassi has a BSc in mechanical engineering from King Saudi Arabia, and he is a former General Secretary for Operation and Maintenance at Omantic Arab Operation and Maintenance Council. Engineer Abbassi, he will talk about conditions monitoring using the variable speed drive as a sensor. So please, the floor is for you. Go ahead.
Thank you, Dr. Rifaat. Assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum assalam wa rahmatullah.
Skin is okay?
Yes, good, very good. Go ahead.
Hi, everybody. I want to talk about the investment of facility management. I want to prove that facility management is an investment, not a cost. The difference in perspective of both investment and the cost is very big. It's a money. It's a big money, maybe millions. And I will show you these millions in one actual example. Really, it's a shock. My concern is your mindset, because I think if you have a belief, you will move, you will change. But if you haven't believed, you will not change. So I will address my speech to your mindset. Our investment either is increasing your capital or decreasing your losses. In our case, assets, our losses in assets is depreciation. And this is my playground in this presentation. Your asset in your organization. I'll concentrate in this assets, emphasize that they have considerable value and how I can improve the services by facility management, how I can increase the value of these assets. Then I'll show you the difference between cost center and profit center, and where I'll select then I will answer the most important question, how I can promote to a profit center. Okay, gentlemen, let us move. Time is very short. First thing, I need everybody to think about his facility. I want everybody to think how he can provide considerable value of assets in his organization. This is the key of my presentation. Please keep it in your mind. To evaluate the value, to evaluate the assets, your assets, you go to your balance sheet. If you go to your balance sheet, you'll find two categories, CapEx and OpEx. In CapEx, you can find biggest or one of the biggest number is your asset. In OpEx, you can find mostly the second after the payroll item is the expenses of these operating expenses of these assets. So if you have these two big numbers in your balance sheet, why didn't invest in these numbers? Why didn't invest in your assets? Why didn't have your plan to invest in your assets? It's a logic. And if you need to create your investment plan, you have to consider two things. The value of your asset, as much as it's high, you have to place your investment plan properly, and the current condition of the assets. I'll go now to actual example. This actual example happened with me. Before, about 20 years ago, my company sent me with my colleague to evaluate one private palace. That palace was used for a short time, and the occupants left and kept it for 8 years without maintenance. Actually, the estimated cost of that palace before the accommodation, construction, fit out, furniture, it's about 280 million riyal, or about $75 million. But for 8 years, okay, for normal condition, if with the 5% depreciation, the cost is about 195 million riyal. This is a normal condition, if it's maintained. But the problem, when we went there, we found the situation is very bad. It's miserable. Actually, these pictures are not actual, only just to show the difference between maintained palace and non-maintained. These are, if you see this palace maintained and see the house clean, and the other one without maintenance. We found that the situation is very bad. Actually, furniture damaged, low current systems completely deteriorated, chilled water, everything is completely damaged. So it was estimated, the cost estimated there at that time, about 100 million riyal only. I mean, the loss is about 95 million riyal. Why? Because we didn't maintain it. We estimated the cost at that time with only 20 guys, cleaners, technicians, guard, because it's not used, the bus is not used, with 35,000 riyal a month. But we didn't do, because that we paid 1 million riyal loss every month. In total, the cost of the estimation for 8 years, it was around 6 million riyal. And the loss, it is 95 million riyal. Because we didn't follow the rule, pay less, get more. We didn't pay this 6 million riyal, so we lost 95 million riyal. This is the investment. This is the rule of the investment. Okay, normally, the people, they are considering FM as a cost center. Technically, it's correct. Why? because it's expensive. And these expenses, we are paying money for these expenses. But strategically is wrong. Why? Because
Engineer Ibrahim, you have 5 minutes to finish. Huh?
Okay. Why? Because we have options, two options. We have give and take. Both hands, same function and same source. You can use for take and you can use for give. The difference is here. Difference in take, cost center for take and profit center for give. Cost center, in the cost center, the facilities, they are used as overhead expenses. Only they need to meet the budget. All the stakeholders or the client, whenever there is a cutting cost, they will go to maintenance and try to reduce. And it's wrong. The team there in the cost center, only they are supporting or just satisfying the users or the client. Normally, the operation maintenance manager, he is getting instruction. Please repair, clean, change. Like this is the service request always. But in profit center, something else. The team, they have different vision. They are providing significant and valuable contribution to the organization's success. How? They are improving, they are changing, they are creating, because they are sharing the stakeholders with their objective. The profit center team, they are showing, they are only looking for a return. Really, they are looking for a return because they are partner, because they are managing the property. They are not all operating, and they are expert, and they are doing added value. They are creating. By the way, difference between operation and maintenance manager and facility manager is a big difference. And you can see in this, as I said, cost center and profit center. Now, if you see that, if you concentrate in this advantage and disadvantage, we can find that there is no extra cost. This is the most important thing. Only just you need to change your perspective. Why I did not do it? Okay, if I believe that I'll go to the profit center option. How I can change my perspective? Now, this is the most important question. How I can promote to a profit center perspective? There is a lot of ways to change and adapt this perspective. I selected 6, which they are practical, and I saw it from my practice. First one, you have to empower your staff to show positive initiative and added value to the organization. You have to think, create, add value, think out of the box. The people there, they are leading. Second thing, you have to share the...
1 minute, Ibrahim.
Okay. Can you give me more? Just please, 2 minutes more.
2 minutes. 2
Yes.
minutes. Because
Thank you. Okay. The facility team, they will look for the objectives the same with the stakeholders or the client. Suppose you have a team, a mall. In the mall, if you didn't improve your services in the operation, suppose you have problem in the power interruption, shortage of water, not clean, not safe, the people they will not come. So you will fail, and the owner, he will fail. Again, we have waste reduction, waste or losses reduction. You have to concentrate, and you have to, because it's a money in this waste. Revenue creation. Actually, these three factors, it has a lot of details, but it's not enough to go for that details. Okay, now facility manager normally he's working as owner of the assets. To work as owner, he should have authority and trust, and he will work efficiently to utilize the assets. Elevator, escalators, power generator, and everything, all the assets there. Now, the facility team also, they can look for the benchmarking. It's a challenge, but it can be done. At the end, savings are the same as profit. If your team do a saving, appreciate them, and so they can repeat the exercise, because consider this as a profit. Don't blame them that this is not done before and you get this save late. Now, I want to increase the value of the assets. How? I'll increase that by optimizing my FM services. See the relation between asset and FM services. I have many ways, but I selected two: cost optimization and process optimization. In cost optimization, I can go for high quality with lower cost. I can increase my application in automation technology, which is now available everywhere. I can make optimization for my workforce. My workforce, like training, awareness sessions, competition. I mean, improve the environmental of the teamwork, and outsourcing of specialized services. Then I will use my skilled and expert people to do the services. The second process.
Ibrahim, can you go to conclusion, please?
Yes. Okay, less than 1 minute, please. Okay, in process, you can find asset, BPM, predictive maintenance, implement, and track. This is the most important thing. Track your progress, VS plan through KPIs to maintain your performance, and e-sourcing at the end. There is a lot of factors which affect your asset value in the design phases, in execution phases, in the planning, mobilization, and major forces. At the end, the investors, they are always looking to decide or to invest. They are looking for life cycle costing. Life cycle costing, it contains two phases: initial, design and execution, and in operation, use and maintenance. These two phases consist of the life cycle costing. My advice, always keep FM team involved in all the phases of the life cycle of the asset, because they will affect to the total cost of the asset. Thank you, and sorry for delay.
Thank you very much, Engineer Ibrahim Al Abbassy, for your presentation. I like just to mention and to highlight to our attendees that the presentation will be loaded in the website, and also we have many questions. It will do our best at the end of the session to answer the question. However, you have the accessibility to send the question directly to the speaker to answer through his communication and his contacts. Welcome, Mr. Tom. We have the third last speakers, but not least, at the session, Mr. Engineer Tom Sevenstein. He is the managing director and of the consulting and training company TSMC at Denmark. Tom is a specialist in the maintenance, management, and improvement production efficiency. He has more than 35 years experience in the maintenance organization with benchmarking, planning, and implementation of CMMS. The experience comes from national as well as international projects. Tom is a skilled facilitator in the maintenance and reliability training. He has published many articles on the maintenance and reliability. Welcome, Tom. Tom was going to give us a presentation over 15 minutes, an integration of maintenance and asset management, a case study from a water utility company. So the floor is for you. Go ahead, please.
Yeah, thank you, Mr. Chairman. Thank you, Omantech. And I would like to, first of all, ensure that I got my screen shared.
Could you share the screen?
Yeah. Can you see the screen now?
Yeah.
Yeah, the water tab.
Yes, go ahead. It's okay now.
Yeah, okay. Thank you, and I would like to give my presentation on a small case study on the integration of asset management and operation and maintenance. This case originates from a utility company in the North of Europe, and I will flip to the next chart. And did I flip the presentation? Did you do? Is the presentation flipped?
Yes, yes.
Yeah, okay, yes. Just to make sure that everything works. And the result of this, which is the primarily takeaway from my presentation, is that the company in this case used the existing operation and maintenance practices as a building block in the construction of an asset management system. And it was basically what was really good for that particular company. And that promoted the existing practices in operation and maintenance to be a part of the strategic asset management plan. That could be stuff like capital investment in short and long term, and it was also the asset management plans. The company, short about the company, it is a utility company which has this business of supplying a city with 1.5 million people with drinking water, sewage, district heating, gas and power. The company was of course a former monopoly, publicly owned, and also a heavily regulated company which put some constraints on capital expenses and operating expenses. The water section, which is one of 6 sections, was a very simple production. They simply drilled a hole in the underground and extracted water from the wells. They had a very old system, but also a system with a very high level of redundancy. And that was caused by the business requirements to always be able to supply the inhabitants in the city fresh drinking water. The challenge, as I mentioned, regulated for OPEX and CAPEX, and also the company was a collection of several independent companies with many different company cultures. So what was the state of art in one part was different in the other. And the response from the management was to introduce asset management, to align the business processes, but also to prepare for an expected requirement and regulations in the future. And since this is a fairly old story, it has already taken place. And at that time, there were many initiatives in the business and many myths about asset management. And of course, that caused a resistance to changes among the technicians in terms of, is this a cost reduction issue and all the other perceptions. Yes, looking at the maintenance practices, the water division, they had in fact an informal prioritization of the assets. Informal meaning that they had a regime for large power pump stations, small pump stations, and so on forth. All the assets were prioritized in the division's computerized TSMC system. So it was possible to see which assets which were high or low. And in general, the maintenance practice was preventive maintenance on all the assets. Yeah. Preventive maintenance performed on the assets.
Oh,
yes.
That's so. Oh, go ahead.
Yes, the requirement was to prioritize the water, or the requirement from the management was to prioritize the water division's assets based on the informal existing prioritization, and to develop the prioritization process to a documented process, not only for the operation and maintenance department, but for the entire business. And that should be used in the strategic asset management plans. And of course, the as the managers, they asked a task force to be established in all the divisions. And it was a good, fruitful discussions, as you can see at the picture. There were many discussions, many perceptions, many different views on what is a high class or high prioritized assets, what is a low prioritized assets. But at the end of the day, the water division technicians, managers, were able to come up with a asset prioritization table for the first edition, and they used the criteria for reduction in production, cost to re-establish supply, water quality, reliability or customer service, and safety. And water quality and safety were more or less mandatory. It could be, the other divisions, it would be not water quality, but different qualities. And safety was, of course, also mandatory for the entire company. But the outcome was that they were able to point at an asset and say, okay, that particular asset has a high criticality score, and the other one has a low one. And we also had what they called intermediate or medium criticality. This asset prioritization table was the first edition, and of course it has developed and been modified, adjusted, but basically it's the same criteria, and the values have slightly been changed. And what they did, they took what was the existing practices in their operation and maintenance department and promoted it into a company standard for, at least for the assets in the water division. And today, and shortly after this process went on, they were able to prioritize at least the long-term investment based on the prioritization table from the operation and maintenance department. So that was basically a promotion of what already existed and a documentation of the existing practices. And the organization, they used a chart similar to this decision tree, where they, at top of the tree, have the classification. To the left and to the right, they have the CMMS system, and this was used for the criticality sorting of the assets, and it was done also inside the operation and maintenance department. The nature of this company was that they had a large fleet of what we would call identical or almost identical assets. That called the division to use what they call generic maintenance concepts, or probably more a maintenance guideline or standard, which was one standard which were imposed on many items, many assets. Once again, they had one procedure, one standard for high criticality pump stations, one for low criticality pump stations, and the same for the distribution grid. So they started to the left with a criticality ranking, and then they used this decision tree to find what if they should use either for the safety systems, they should use existing standards. If they had it was a generic component, then it would use the standards as well. And the most interesting was if we had an asset with a low criticality ranking, then the decision was to run for deferred corrective maintenance. And please take in mind that the existing practice was to go for preventive maintenance, but this decision tree and the criticality sorting changed that strategy. And the results and the learning from this exercise of prioritizing the assets was now the company has one way of prioritizing the assets. It's not only the operation and maintenance department, but the entire company has one way of looking at the importance of a given asset. From the maintenance and operation and maintenance department, it also forced them to change from preventive maintenance to they went from the previous regime of preventing maintenance to inspections or simply run to failure. And that was an example where they benefited on the high redundancy inside the distribution grid and the production grid. So the perception before this exercise was that all the equipments, all the assets were very important. But today they have realized that only 10% of the assets could be categorized as high criticality, meaning that 90% has a lower criticality. It was also an example of stakeholder management. This, at the start, there was the human resistance to changes, and that was reduced because the process was that the existing practices was promoted into what would be a company standard. And also my takeaway from this was when you are implementing asset management, please, my advice would be, to use existing practices. Of course, I recognize that if there is any requirements from the given standards, whether it's ISO 55000 or it's any other standard for asset management, there could be some requirements which forces the current practices to be changed. But my recommendation would be to use the existing practices and promote those as company practices instead of only operation and management practices, or operation and maintenance practices. And then, of course, the key word with asset management is, in my view, systematic and integrated processes. So in this case, we were successful by achieving that goal of having one process for prioritizing the assets, which were used in the project department, in the development department, and also in the operation and maintenance department. So it was, from that kind of view, a very good story about asset management. That would be my final and conclusive remarks from this case story from the water company. And I would take the liberty to open if there's any questions, any comments to my presentation.
Very much. Thank you very much, Engineer Tom, for your nice presentation. We have 10 minutes left for question and answer. So I have some questions from our attendees. I think the first question from Mr. Ramesh to Dr. Norbert. He asked about what about the speed monitoring? Can you give us some explanation about the speed monitoring, right?
Well, first of all monitoring we do is relative to speed. So you can see in this graph here, the vibration level is shown relative to speed. If in application the speed itself would vary, then you would detect it as a change in the torque, because how a motor, the drive sets the speed of the motor. And if the speed of the motor is not the same like the set speed, that means the load influences the motor, and that would be then influenced as a load change. But all parameters shown here are shown relative to speed.
Yes. Okay. I have also questions from our colleagues to Engineer Tom about the case study of asset management for water utility, where it has been conducted. Can you give us some more information about the asset management and the outcomes of the asset management? What is the outcome of it? Do you have?
In general, for this project, I would say it was from a top view. For this particular company was one, to align the businesses, because there were several business processes in the company, and also to have a common view on what was important for the business, which assets were important, which were less important. So, but from the high level perspective, it was alignment of the businesses and the processes, so all departments had the same view on the assets. They were working on the same value of the assets.
Okay. Okay. I have also some comments from our colleagues that he said that sometimes if you replace an asset rather than doing maintenance, will be much less costly than maintenance cost. How we will be able to calculate or determine the maintenance cost versus replacement asset value?
Is it for me or
For whom, Doctor?
Is it for you? Yes.
Yeah. The cost for asset replacement value. There is some rule of experiences by which where you say if the cost to maintain a unit is higher than there is some rule of experience if the cost to maintenance is higher than to get a new assets, then there is some recommendations on. But I'm just curious about the threshold. I can't find it. I can't identify it from the top of my head. So, but what I would do would be to simply oppose a life cycle cost analysis and say this is the life cycle cost for the existing assets under the existing maintenance regime, and versus the cost for a new assets. In fact, we did a workshop together with one of the colleagues from Copenhagen Airport at one of the previous conferences, where we had a number of cases which gave the answers of what is the cost to maintain and what is the cost for reinvestment. So okay. I hope that and you're welcome to contact me if you still we got the presentation if you're interested. Yeah.
Okay. Yeah. Okay. Also to Tom, typically in water and sewage treatment facility, there are a lot of assets that are similar and identical, pumps and for example, when you define the maintenance task and the failure mode of FMECA, do you copy paste to the library, or do you reinvent them to each specific case? It seems your presentation is very interesting, so I have many questions. Huh?
Yeah, thank you. First time the company made a the practice was the first time we made what we called a standardized unit or standardized assets, which were common. We did a Familia root cause. I think we used RCM in order to make that, and that RCM analysis was then promoted as a standard for that type of equipment. And every time we met a similar asset, we simply looked at the maintenance standard and say, this is what we will impose on that particular unit. Is there any differences here? And then, of course, there would be some adjustment, but it was very, very few. And then we imposed the same regime on that particular asset. And that was the process. So simply take one, allocate it to the other identical assets, adjust it for there were any differences, and then simply impose it into the CMMS. But in general, and that was particular for the Sewage division, they ran for several years with 3 practices for pump stations for sewages, high, low, and medium. I don't know, it was small, large, and medium also. So that was a way to shortcut to get not a perfect maintenance regime, but not reasonable, but a good enough maintenance regime versus a very detailed RCM or similar Familia planning process. So bottom line was take one and promote it as a guideline.
Good, thank you. I have another question for Dr. Norbert. So which capacity of the motor you recommend to use this device?
Yes, this can apply to all motor sizes. So we have seen this used in small applications, 1-2 kilowatt, for example, in beverage bottle lines, the drives that run the conveyor belt. We can see it in hundreds of kilowatts big pumps. But the decision at the end of the day, I think you better listen to Tom and his explanation about the criticality of the application, because that's where the answer comes from. The technology itself works at any power.
Okay. Again, to Engineer Tom, there is a questions asking you about, is there a specific asset management software that has been deployed or it was locally developed?
No. The software, the CMMS they had, that was one of the international big ones. I can't remember if it was. At least it wasn't. It was one of the international which were available on the world market. It was not a local development. I can't remember from the head which one it was. That's it.
Yeah.
And there was no. It could have been anyone. There's no relation from the CMMS to this case study.
Yes. Do you have any questions to ask? For example, you know, if somebody from yourself for the panel want to ask a question quickly? No? We come up to the end of the session. We'll thank you all. Thank you very much for your nice presentation. Thank you very much, Dr. Norbert. Thank you very much, the Engineer Abbassy and Engineer Tom.